All right, good afternoon, everybody. It is 2 minutes after the hour, so I think we should begin. I'm sure we will have more people join the webinar, and as time goes on, we would love to leave some time for question and answers. Hopefully the chat facility in GoToWebinar works, so if you have a question, we would love to hear it. Please leave it there, and we will monitor that window to see if we can inject your questions into the discussion. But to start with, if you don't mind, go to the next slide. A brief introduction. My name is Misha Gopstein. I'm the Chief Executive Officer here at Microfab. Prior to Microfab, and I've been at Microfab for about 4 years, I founded a cybersecurity SaaS company, worked for a long time in securing data center environments, and then later one of the first security systems for Amazon Web Services, Google Cloud, Azure. So have a lot of experience with both distributed systems, large-scale computing systems, but especially the changing paradigms where you're moving from one computing model to another, which is a shift that I think is also happening in a supply chain world, and it's by far one of the most interesting shifts in our lifetime. There was obviously a very exciting time when cloud emerged as the new computing paradigm, and there's been a lot of companies that were created that really couldn't exist before cloud computing came into fruition. I think we're going through another such shift with manufacturing and supply chains, and it may feel like we're in a period of turmoil right now, and we certainly are, but that's actually how new models emerge, and that's how new models enable different types of delivery systems to get built and fully realized. So if you don't mind, go to the next slide. Let's talk about agenda for today. One of the things we're certainly going to do is discuss what do we even mean by cloud manufacturing. Sure, it sounds like a term that marketing people invented, but it's real, and it's actually happening in multiple domains. We've seen cloud platforms have a huge impact, certainly in all walks of life, but now are starting to see it in supply chain and logistics. So we'll give you a couple of examples of that. We're going to identify why we're seeing slowdowns today and what exactly is driving those slowdowns, why things that used to work before really no longer work now. I think there was a feeling for some time that maybe that slowdown was temporary, but in fact, we may be in for a decade-long process where we really got to rethink the way we build products, and that requires figuring out what are the bottlenecks, what exactly is slowing down, how do we accelerate it? And frankly, there will be some surface area that is unaddressed and still continues to be a concern. This is still going to be very much a global supply chain, so it'll be a very long time before we can really make sure that we're resilient at every junction point. But the first step is to decouple the pieces and make sure that you can identify exactly what you can accelerate along the way, because once you actually start to rethink the model, there are opportunities to reduce costs, get to market faster, really not be affected by radical shocks that we've seen over the last 4 years. So it's not just adopting new models for new models' sake. It actually has an impact on the business, and we're seeing even some of the largest companies in the world really start to think about, how do I move faster, launch new capabilities, and use these new technologies to deliver products faster than I could before. And ultimately, we'll close out with just a couple of answers on what's possible today and what we need to keep building for in the future. How do you set yourself up for maximum flexibility and make sure that you have resilience built into your long-term plan? So let's go to the next slide. Always good to take a pulse of where people are. Surveys are usually a really good instrument for that. There's a lot of people out there that even in the pandemic, time to market was their still top objective. And when we talk to our customers, innovating and really bringing new solutions to market, they can get around their competition and get customers, in some cases, relief to a supply chain that frankly hasn't been working for a long time. And in some cases, just getting a competitive edge has still been one of the top priorities for people. Not everybody is defensive out there, so not everybody's looking for better gross margins, better earnings, more defensible business models. Some people are on offense and they're developing new technologies. There's a lot of really exciting products being built, and yet we still see products not getting to market on time and launch and miss launch dates about 12% of the time, which at least in my estimation could be an understatement depending on complexity of the product you're actually bringing forward. Foresight and planning and really having the right game plan ahead of time can put you ahead, but it's not automatic and it's not guaranteed, and it's certainly not going to happen if we continue to build products the way we've always built them before. So I would imagine if you're in the supply chain world today, there's a lot of frustration. So if you go to the next slide, I would imagine this echoes a lot of what we've been feeling for the last 3 to 4 years. There is just a general feeling that everything is chronically late. When we need product, we can't get enough product to sell. There's a new problem around the corner all the time, and it started with tariffs originally, then obviously things went haywire with the pandemic. Supply chain went out of alignment very quickly and really hasn't been right since then. And a lot of people have a lot of opinions about why that's happening, but the reality of it is that there's just been a lot of change introduced into the system that wasn't designed for rapid change. Nominally, manufacturing grows by about 3 to 4% a year. That's typically aligned with GDP growth in most Western countries. The amount of product, for example, that we've been importing from, let's say, China is 20% higher than it was before the pandemic. So there's been very much a supply shock, but it's also been driven by uncommon demand, and that means that nothing's working right. And I'm not going to rehash that here. I think everybody is already fully aware that there's a lot of ships that are moving slower than they used to, and it takes, it used to take 13 weeks to get across the ocean. Now it takes, in some cases, up to 4 to 5 months. The prices for shipping skyrocketed. They've come down recently, but delivery times are still slow. You can't unload ships. And particularly if your supply chain in some way, not just sourcing raw materials, not just sourcing subcomponents, but especially if you're delivering finished goods from China, there's not exactly a comfort level that things are back to normal. In fact, COVID is continuing to evolve. We're still seeing significant lockdowns in Asia, and we're certainly seeing COVID take out people at factories in the West as well. So there's still very much COVID impact, and so for a lot of people, what used to work no longer works, and it feels like there's a lot of pressure out there for. So unsurprisingly, people are making other plans. So if you go to the next slide. This is a McKinsey survey, and you can say a lot of both positive and negative things about McKinsey, but one thing they do have is a very broad view into where things are going. They work with very large corporations out there, so they have a good beat on exactly where things are going in a supply chain world. In their latest surveys, the results are pretty clear. What's at the top of the list for a lot of supply chain executives is the need to increase resilience across the supply chain. It's obviously way too brittle, and we can't just wait for it to snap back to normal. It's not going to go back to normal. We will continue to see volatility, and I think the war that broke out between Russia and Ukraine is a good indication of that. Nobody out there that makes their living forecasting thing is forecasting more peacetime and more and revert to the mean, where we're forecasting more turbulence out there for sure. So people are getting ready and people are starting to make changes. The question is how and exactly what changes they're making. For a lot of people, that means increase the role of digital technologies in their supply chain, which sounds like a pretty lofty goal. And we for years have been listening to, frankly, word salad like Industry 4.0, which was supposed to transform every aspect of manufacturing and supply chain. It may actually, in fact, be happening, but I think the term has gotten very much long in the tooth, and nobody exactly knows what it is at this point. It would be a mistake to say Industry 4.0 is what's going to save us. We need to get a lot more specific about what's broken, how we're going to fix it, and what are the exact root causes of the failures right now, and how do we address them. So let's talk about that, and let's talk about what's really not working. One of the problems, and if you go to the next slide, we'll start to explore the reasons why things aren't working as intended. One of the big reasons why it's been so difficult to not just launch products, and not just bring them to market, but even products that have been in the market for a long time, continue to build them and continue to deliver products where the design may have been finalized for a number of years, is that the product development cycle, life cycle in electronics is overwhelmingly waterfall based. When you look at software ecosystems, they've long ago moved away from waterfall models. Initially, Agile was the model that everybody adopted. There's a raging debate now about whether Agile is even a good idea, but that's not the point. The point is that we know that waterfall, while working, only works at a steady state, and really works in environments where you don't have to make rapid changes. And in fact, in this environment, you do, because as we already mentioned, what we're seeing now is an environment where you may have a design for your electronics product. That design, even when it's being produced already on a factory floor, a lot of times runs into a brick wall. Materials go out of availability. So what we're seeing with our customers is a radical shift in how they're running their design cycle. Products that have been finalized for several years are going back to the drawing board, and engineers are in real time designing 2 to 3 iterations of the same product with a different BOM, just to give their supply chain team some breathing room and give them an ability to accept substitute parts, which sounds easier than it is. You obviously are changing the design when you do that. Sometimes the substitution is as simple as saying, hey, it's an equivalent part, tolerances are in spec, and we don't have to worry about design change. In some cases, that means, the biggest constraint has actually been about integrated circuits and some of the more active components. In some cases, requiring software changes. These are very rapid design cycles, and the electronic supply chain was really never built for that rate of iterativity. And that absolutely affects the factory selection, how you build it on the factory floor, and the need sometimes to move to a different factory. So if you go to the next slide, here's what actually happens when you couple the product design cycle and the typical design stages with your factory selection process. Overall, as you go through your traditional EVT, DVT, and PVT design cycle and get to a mature product, you're actually moving between factories more often than not. And when you're moving through factories, each one of those moves ends up taking 2 to 6 months. The reason why you move between factories is actually fairly rational. Not every factory is built for every unit of scale. There are factories that are really purpose-built for very small prototypes, and in some cases, really build subcomponents for designs that are bench assembled. And up to 10 units, people are really just ordering components from various sub-suppliers and assembling them themselves. At some point, they may find a contract manufacturer that will build in hundreds of units quantities, and then things change as they move up to higher production scale. So if you go to the next slide, this is what it really looks like, and that's what the real world actually entails. You're really having to switch factories at every stage of production. Eventually, you end up having to face the choice of having to get your price of your build down to a reasonable level. A lot of times in the past, that has meant offshore to China, and it's a combination of China has historically been one of the least expensive ways to build product. More important, there's a lot of expertise in China. So when you're moving from a functional design that you can build in hundreds of units, but what you really need is to scale it up and to be able to grow your supply chain and really be able to go to a place where they build products all day long, and there's a huge ecosystem of suppliers that can help you cost down components, dial in the cost of your fixed cost and your materials, for example. There are few places better to build than in China, but I think what a lot of people have realized over the last couple of years, it's not nearly as good as it used to be, and one of the reasons is that labor costs in China are actually going up. If you actually look at raw labor costs, they're actually significantly lower in Mexico at this point. The gap is actually not in labor cost, the gap is in capability. So this notion that you go to China and it's the most reliable, fastest, and inexpensive way to build is no longer true. So a lot of people are really reconsidering what they're going to do and how they're going to build their products. As I mentioned earlier, today, if you're still building in China, chances are you're having some kind of a problem. Either your factory is getting shut down with zero COVID policies, or you're having trouble moving all the materials into China for final assembly. Even when you assemble the product, getting it put back on the ship and getting it back to US is a difficult exercise and very unpredictable. There's a lot of customers that are still waiting for their deliveries and really can't forecast accurately enough, and end up in a situation that we find a lot of consumer and retail world in right now. There were so many orders placed with China that companies like Walmart and Target had a shortage of inventory last year. Now they're reporting record inventories as these ships are coming into dock, and there's a swelling effect in warehouses in US. Same exact thing is happening in electronics. In fact, I was just listening to CNBC on the way into the office, and they were talking about how there's a glut of chips, and the chip crisis is over. That is not actually what we see with our customers. In fact, what I think is maybe over are some very specific chips that are used in auto production. But overall, it's still very difficult to get the last golden part for your bomb. And people are still in a situation where they have a lot of demand. They'll place large orders. They will start to buffer a lot of inventory, and eventually their demand forecast may go upside down. They may end up with more product than they bargained for and need to actually slow down production and change their game plan going forward. For anybody in the supply chain world, that's an extremely difficult thing to do. So there's no shortage of problems to fix. At least theoretically, you can wave a magic wand and say, what if we move to digital platforms? Would things be magically better? So if you go to the next slide, we'll go through the promise of what these platforms offer. So to kind of recap what we've seen before, waterfall development is slow, doesn't really allow for fast iteration. Fast iterations right now are what we're seeing with all customers. They're all changing their designs very quickly. There are supply chain delays. I don't see them slowing down. I see different components now at risk than I did a year ago, but still, it's very difficult to put the full BOM for a customer. We have a lot of customers that are coming to us saying, look, buy as much as you can, build me a buffer stock of materials in your warehouse to make sure that I can go to production whenever I need to. And so the people are still very much in source ahead mode. And there's obviously a hidden cost of not just engineering time, but also supply chain time in just never-ending phone calls, emails, and meetings, where you used to be able to throw the design over the wall, and it goes from engineering to supply chain team, it goes to sourcing, and those teams may not talk to each other again for a very long time. They are now heavily involved, collaborating all the time. So theoretically, digital manufacturing systems can help you really put in place a much more efficient system where you can rapidly prototype and really enable engineers to run prototypes much faster, capture that digital design in your digital manufacturing system that is already aware of which components are available, which components are constrained, which substitute parts you may need to be able to get. So really prepare itself for resilience. Get access to a lot of factory capacity. This is one of the things that's amazing about some of the platforms being built now. You're not dealing necessarily with a manufacturer where you get homed into a single factory. You actually are operating in a network of factories where your design may be on a persistent factory floor, but you're actually working with a company that has access to hundreds of production lines and actually has a lot of optionality to move you to a production line that either moves faster or is currently not constrained. So there's a lot more ability to load balance and dial in your production and really make sure that you can accelerate when you need to. And ultimately, the premise, and I don't think any of the companies in this space would say they're done, but more and more of the workflow should be software enabled, right? For example, when very simple use case, right? When engineers are selecting alternate parts, it's one of the most time-consuming things and one of the biggest things that introduces a long cycle loop where a manufacturer, a factory might go to a supply chain person and say, hey, I can go to production, but I need your approval on this particular part. Is this part approved? That part goes to the engineer. They ask them a question. Can you actually accept this part? Will the product still work? None of that should really be phone calls and emails. In fact, ideally, you have your substitute parts predefined in the digital platform, and that gives the supply chain team the ability to source optionality and really say, look, if you can't find this part, you have a pre-existing green light to go source 3 other components on the depth chart of that constrained material. If you have all the information at your fingertips, if you can see what materials are available, what materials are constrained, and what your optionality is, right? What substitute parts you can source, that becomes a lot easier. All of a sudden, the meetings, the phone calls, and the iterative nature of having to go back and forth between supply chain engineering in a factory and having to rinse and repeat goes away, and it gets much easier. And that's just one example of what software-enabled workflow can enable in manufacturing. We're seeing that happen not just with electronics, where Macrofab is focused, but obviously with other parts of the supply chain. So if you go to the next slide, at a very macro level, we've obviously seen digital platforms, thoroughly upend the world out there. When we need to get somewhere, we call on Uber, and that's the largest service by far that lets us tap into just an immense number of cars out there, not just taxis, but obviously other modes of transportation. Etsy gives you access to untold number of craftsmen. Again, we can buy things we never could find before. So you've gone from a situation where you go to a flea market to a site like Etsy, Airbnb, not going to rehash what they do, DoorDash, right? These are, if you need to order food, if you need to order lodging, there are digital systems designed for that. We are just now seeing the emergence of that kind of convenience and really digital aggregation of a lot of capacity in the supply chain and manufacturing world. That's obviously the business we're in at Microfab, but we're certainly not the only ones. One of the things that people don't realize is that a lot of supply chain and a lot of logistics resources, when they're scheduled by humans, are actually underscheduled and underutilized. So for example, Flexport does a lot of modes of transport, but container ships is their bread and butter. A lot of times container ships are not loaded most efficiently, and there's about a 40% delta between what you can put on in a container versus what's actually on it. So they use a lot of technology to make sure they can fill out those containers. Convoy does the exact same thing, but does it with land freight, and they're doing it with trucks. There's a whole cottage industry of companies like Convoy. Zetwork, fascinating company. They're helping you build mechanical parts and really give you access to a ton of machine shops, cast metal shops, metal stamping. You can build a crane, for example, with Zetwork and really source very heavy materials from the Indian subcontinent. We are going to see similar networks start to get built in China and other places. In fact, Xometry is doing something similar, and Xometry has a network of 3D printing shops, machine shops, metal stamping shops in North America and Asia. So they have about 5,000 factories they can tap into. And Microfab is building the same approach for electronics, right? We are focused on North America. There's about 2,200 factories focused on electronics in North America. People are actually always surprised how much gets built between Canada, US, and Mexico. It's actually quite a bit of product. It's 1/5 of all worldwide electronics production. Electronics is about a $500 billion market worldwide. The high volume electronics certainly gets built in Asia, but a lot of mid volume and especially aerospace and defense gets built in US and Canada directly. Automotive, a lot of it gets built in Mexico. So, and these factories, very similar to the problem the Flexport is solving, are underutilized. In some cases, the best factories in the world, but not easy to get into. And somebody's got to be able to aggregate them through a digital platform and then give you as a customer access to some of the best factories, really match up the right job with the right factory at the right time, and give you access to factories that are on this side of the world and are ready to build products for you. So if you go to the next slide. So when you use these digital systems, here are some of the best practices. First of all, it's not enough just to have a network of factories out there. You really want to make sure that supply chain is visible through electronic APIs. We've seen the distribution world, Avnet, Arrow, certainly DigiKey and Mouser expose their stock through APIs. So there's really no reason why you have to be calling and getting quotes for parts. You should be able to log into a platform like ours, for example, and be able to see the stock in real time. It helps the designers, it helps the engineers, certainly helps the supply chain people as well. You should be able to tell which parts of the supply chain are constrained. You should have a single digital record of the job, right? You should be able to say, look, the job that the design that my engineer just modified, I have high confidence that is the exact design that's going to be built on the factory floor. You would be surprised how often that's actually in conflict today. We've seen products which were designed 10 years ago, and the design in the engineering tools, either in CAD tools or EDA tools, looks one way. It looks radically different if you were to look at what's actually getting built on a factory floor. A lot of substitutions have been made. In some cases, blatant design changes that were never authorized. So right now, that is disconnected with digital tools. You actually can make sure that the right design gets built in a right place. And obviously, these systems should be linked to your project management tools to give your stakeholders all the tools in the world to be able to move faster and not always have to pick up the phone, schedule a meeting. If you're an engineer on this webinar, I assume you hate meetings. So the time, when a lot of the information flow is digitized and really flowing to you either through tickets or through native systems that are plugged into directly your EDA tool, is very close. In fact, we just a couple of months ago announced our integration with Altium. When that product goes GA, for example, you'll be able to order products for Macrofab directly from your Altium environment and have confidence that those same designs are going into production scale factories on a factory floor, and nobody tampered with that design, changed it, or modified it in some way. So move to the next slide. One of the most common questions we get asked is, that sounds great, but what exactly can these digital systems handle? Does that mean that in the future there's no Foxconn, there's no Flex, there's no Sanmina? That's not the case at all, actually. In fact, the space where digital platforms have the most impact are certainly prototypes. You can now order prototypes and start your product journey with a lot of these digital platforms. It's a really good fit for low volume production, so products built in hundreds of units, and products that are being built into hundreds of thousands of units. Our largest customer is doing about 1 million units a year with us, but they'll still be very large manufacturers, and they're the best at what they do. At some point, when you're spending about $20 million plus per product, per SKU, nobody's going to be able to build Flex and Foxconn in that business. They can do it at the lowest possible price, and they can do it at the immense scale. So I think what's going to happen with digitization of manufacturing is that mid-volume and low volume is going to get very much digitized, and eventually we're going to see linkage between these digital platforms and the tier one vendors, to where you build your product and design your product in a digital world, you scale it up to a certain production scale, and eventually your product is massively successful, and the only real question is, can I get the price down to the point where it's the lowest it can be anywhere in the world? It can really be built in some of the highest scale environments. Perhaps you're the next Apple, and you need something on a scale that which Apple builds. These digital platforms will essentially become feeders into the traditional tier one manufacturers. So I think long term, we're going to see a situation where tier one manufacturers are automating a lot of their production. You'd be surprised. I believe Foxconn, for example, is one of the largest buyers of robotics equipment out there. So their future is actually not based on human labor. They believe their future is in massively automated factories, but somebody's got to deliver machine readable instructions to these factories. And I think digitization of products, when they're going through the design and scale up stage, manufacturability, get into some level of production that you can actually transition to potentially a fully automated factory in the future. That's an essential step to doing that. You need that middleware, which really today doesn't exist. For years we've been told that ERP and MRP systems and some of the PLM systems are going to be the digital record for that information. I don't believe so. I believe digital platforms that actually execute jobs on real factory floors are going to be the source of truth for this data, and that's going to be what drives production in some of the largest manufacturers in the world in the future. So moving on to the next slide. I'm not going to spend a lot of time talking about Macrofab in this webinar, but I'd be remiss if I didn't tell you some about what we do. Our cloud manufacturing platform is really built for electronics. So at the software level, we really operate as a single source of truth for all of your designs, right? Ideally, you're starting to build your designs through the Macrofab platform. We can deliver prototypes in as fast as 10 days. We have versioning and change tracking built right into the platform, so you can always go back and retrace your steps, not just from a design perspective, but also from the BOM perspective, and really see, look, I took this version to production, something happened, and I don't like where my product is going. Can I backtrack and figure out exactly what changed? Is it a mechanical component that I introduced into that build, or is it a change that I made in my design? That version tracking is built right into our software. You can see it online. We have links to all the major distributors, so you can see real-time component prices. You can do modeling to see what happens when you go from 10 units to 1,000 units to 100,000 units, really understand whether your product will ever be commercially viable. But I think most of the meat these days is really all around inventory logistics management. When we go to production with our customers, we are sourcing all the materials for those customers, so they get to see what their inventory looks like, how many components they have, whether they have a BOM ready for production, and then how that inventory gets exhausted as we're building product. Same thing happens with finished goods, right? For some customers, we're actually storing finished goods in our warehouses and are delivering them on behalf of our customers to their end users. And all of that is available through a modern API and gives you access to hundreds of production lines all over North America. So we're giving you access to factories that can build anywhere between hundreds of units to hundreds of thousands of units, anywhere between US, Canada, and Mexico. So if you go to the next slide, the way this looks up close is that you start your design in our platform. Eventually, you start to place larger orders. Our team will work with you on making sure that we are sourcing the right materials, not just from the electronic parts perspective, but also actually make sure that we're sourcing the right mechanical BOM as well. And factory selection is a hybrid of algorithms that are aware of quality, capabilities, and product mix and volume of those factories. We are inspecting every product that gets built in our factories in the Macrofab quality facilities. So we have a really good record of what factories can do really well and what they can't. So over time, we're building a really good record of the best factories in the world and what they're able to build successfully. So we can match up a small job with a small factory and then place a large job on a persistent factory where it's going to stay there for potentially a couple of years and really gain the benefit of that tribal knowledge and awareness of how to build that product, but always available to size up or size down. And we've had cases where somebody needs to be able to manufacture much faster, and we've been able to put them into 3 to 4 factories in parallel and handle that burst capacity, even if it's for 3 months or so, and then scale down again to a smaller size. So a lot of promise in what we're doing. We have a team in Houston, which works in a large warehouse and a large production facility focused on prototypes and NPI. We also have a facility in Guadalajara, so we can source materials from either one of those locations and be able to get around tariffs, construct a full kit in either one of those locations and put kits on a factory floor in either US, Canada, and Mexico. Go to the next slide, please. So I've introduced the concept of not just digitizing your supply chain, but also potentially moving it from Asia into US and Mexico. And I want to spend the next couple of slides walking through the premise of that. A couple of years ago, reshoring was something that we saw in the press. It's something we saw people talk about, but we really didn't see a lot of companies in a meaningful way choose US or Mexico over China. We are in fact seeing that, and it doesn't mean that China is not producing a lot of product. As I mentioned before, exports from China are at an all-time high. In fact, they're having trouble scaling beyond the capacity they have right now. Just a couple of months ago, there was a energy shortage in China, and factories were shut down because they couldn't get enough power. So it's not as if there is a stampede coming out of China, but we are seeing more and more designs either leave China for other locales. A lot of times it's in other Asian countries, but a lot of them are actually coming back to US and Mexico, and depending on the type of build you're doing, there may be a really good reason for you to be in US and Mexico. A lot of it depends on the type of build you're doing and whether or not there's a lot of labor built into it or not. So I'll give you an example. When you're building consumer electronics products, especially things like iPhones, right? There's actually a lot of human labor involved in that process. And in terms of getting access to a lot of labor capacity, Asia is still the best in the world to do that. And when you have a mix in your product where there is a lot of manual labor involved, scaling that in Asia is still by far the cheapest way to go. And it's not China anymore. As I mentioned, China, labor in China is actually more expensive than it is in Mexico now. Where we're seeing things go is now into Indonesia. Vietnam is super busy. these countries don't always have the infrastructure to pick up massive manufacturing jobs from China, but they're running as fast as they can there. Now, for things like industrial manufacturing, automotive has always been in Mexico, where there's a different mix between automated component placement and manual labor, especially where manual labor is a smaller part of the job. We're actually seeing where US, because of automation, can be competitive, and Mexico can either be very comparable to China and in some cases cheaper, right? So if you go to the next slide, I'll give you a couple of examples that were done by a couple of studies that were done. So this is a mechanical component. That's not a that's a subcomponent to an electronics build, obviously. But the visual here is that it used to be much cheaper in China about 10, maybe 20 years ago. Something that used to be $5.40 in China 10 years ago now cost about $8.60, and really in some cases on par with what you can build a same mechanical component in US, and you potentially can build it slightly cheaper in Mexico. If you go to the next slide, this is more related to electronics actually. So in this particular snapshot that I used, this is for low product value density and kind of medium labor content, right? So this is not a consumer product, nor is it a highly automated product where there is a lot of expensive ICs. There's a high BOM value and very little labor. So this is right down the middle. As you can tell, China is about 25% cheaper than US today. I think that delta is surprising to a lot of people. It's less than they think. I think people have that visual in their minds that China is significantly cheaper. When you actually factor in the cost of logistics and fully landed cost and tariffs, it's only about 25% less than US. And then the question becomes, how much would you pay to do your final assembly closest to your customers, to where you don't have to disappoint your users and disappoint your sales team, and really build closest to your customers? You may still be in a situation where you're sourcing globally. Some of the subcomponents might come from Asia. In fact, in some cases, it's inevitable, right? We still see a lot of semiconductors come out of Taiwan. That will be the case for the most advanced semiconductors for a very long time, where I think US is investing $50 billion into new semiconductor fabs, but they're not going to be online for at least 5 years, and who knows when they're actually going to be making an impact. Same thing with PCB fabrication, right? There's some PCB fabrication in US, usually low volume and much higher prices. There's none of it in Mexico. So if you're ordering PCBs at high volume, they're usually coming from China or Taiwan, but final assembly can and should be done potentially either in US or Mexico. I would argue that North America, for North American customers, is the right place to do final assembly. And I think Mexico is by far the best locale for that. So we have a lot of customers using our platform to make those trade-offs, right? They're essentially saying, look, what I really want is the flexibility to be in North America and closer to my customers. I want to stop waiting for product to get off the boat. And I want to be able to, even though it might take me, I might need to have long lead times for some of the components, final assembly, I want to have a lot of control over. They finding that there are a lot of times when you do fully landed costs, it's actually cheaper to build in our network in Mexico. And in some cases, it's worth building it in US. And especially with a platform approach like ours, where we have access to hundreds of production lines across North America, you can actually mix and choose, and you can say, look, this SKU, I want it to be done in US. This SKU is going to be higher volume, and I need it to be more competitive than China. Let's put that into Mexico. And that's really the beauty of dealing with aggregation platforms that let you have access to a lot of factory capacity. For most customers we deal with, they're not dealing with one or two products. They're dealing with an entire product catalog. In some cases, that product catalog has legacy parts in it, right? Their customers are still buying and actually have the highest margin in their business, but maybe not the highest volume that they produce, and the need for that product is irregular. Digital platforms like ours are actually one of the best places to, first of all, put that design, know exactly where that design is, and be able to scale up production whenever you need to if an order comes in from a customer where the margins are super high, and if you can build that product quickly enough, they're happy to go buy it from you. I think this is one of the most underutilized use cases for not just North American production, but also North American production through digital platforms. And we're going to see more and more of those case studies emerge, and those stories being told. They're being worked on as we speak. I've been blown away by the kind of companies that are coming to us and saying, look, I have products that are kind of last in line to get built to use giant factories, but they're actually very important to a small subset of my customers, and I need access to agile factories either in US, Canada, or Mexico, so I can go to production quickly and capture that demand. So to start to wrap up, what we really want to do as we're going forward is start to eliminate risk from the supply chain. And as I mentioned, you're never going to be able to get out of the global sourcing picture, right? We're still going to source semiconductors from Taiwan. We're still going to source a good number of PCBs from China, that is the world leader in PCB fabrication right now. But your final assembly should arguably be closer and closer to North America, and you should be in a situation where you have a lot of optionality in which factory you're going to use and which factory you're going to have access to exactly when you need it. It all starts with letting engineers iterate faster. In fact, I've seen this happen in the software world, and it's really happening in the electronics world as well. When I first started working in this industry, I was meeting a lot of, frankly, disappointed engineers that felt like they knew a lot about the product that their company was building, but their input wasn't being considered and wasn't, and a lot of times could have saved the company a lot of trouble. To give you an example, right? I talked to an engineer that dealt with very complex, super dense designs, and he really knew a lot about how to choose the right PCB fabrication facility. He was probably the most passionate person I've ever met about drills at PCB fab houses, and knew exactly how to select the right suppliers in their supply chain. But he said, look, that's not the way it works. They don't use my expertise in order to go choose the right suppliers. They go choose a supplier because it's the lowest bid. Then they come to me and say, why doesn't it work? Then I get involved. I think enable engineers to be part of the supply chain process is essential. That's not just software, and it's not just macrofab or Xometry or other platforms giving you software that enables people to move faster. It's also a cultural change within your organization. If your teams are collaborating, I guarantee you're going to start to see significant changes in how easy it is to build your product, whereas right now it may be impossible, right? I think a consistent digital record of your design across the entire value chain is table stakes. There's if you listen to podcasts, there's one going around now where somebody said, look, we need, and I mean, this is going back to the COVID days when we still thought we needed a lot of ventilators. Somebody wanted to go build a lot of ventilators and realized, you know what, nobody has this design. It went into production, 15 years ago. The engineers are long gone. Nobody knows where the files are. So they literally had to start by 3D scanning every part in that ventilator in order to go put it into a Ford plant that was getting bootstrapped for ventilator production. That is what happens when you don't have control of your design and are not sure if the design that is in your PLM is the design that's actually being produced on a factory floor. And frankly, that's not something that you have to take as a standard rule of business. That's not the way things have to work. You can work in an environment where you have 100% confidence that the design that your engineering team specified is the design that's actually being produced. I think digital platforms are the way to get there. I would start getting your ducks in a row to really diversify your sourcing as much as possible and really decouple sourcing from factories. Right now, the way that you outsource electronics, chances are is you go to a contract manufacturer, and if you're working with them on turnkey basis, you say, build the whole thing. You source it, You figure out how to build it properly. I want you to test it. I want you to deliver finished goods to us. And then slowly, if you're finding that there is slowdowns in the supply chain, you may be forced to go find materials yourself, consign them to that manufacturer. I think the answer is in decoupling factories from the sourcing function. You should be able to source globally, but build locally. I think that's the stable state you want to be going to. Once you start to get into that posture, you actually gain a lot of resiliency, and you get a lot of flexibility about which factory you're going to be in, be able to move from one factory to another. Things happen in factories, right? They get sold, people quit. Sometimes good factories become bad factories overnight. You need optionality. You need to be able to have factory portability. So if you're with a supplier where the only reason your product can get built is because there's a magical team of people that remembers how to build it, you're at risk, right? At some point, one of them is going to quit, one of them is going to retire, and your product's going to go into flux. And the time to address that is now, not later, right? So that concludes our story today. I'm certainly would love to see if there's any questions out there. So I'm going to check in with our team here and see if there's been any questions submitted.
Yes, if you have any questions, please put them in the question. I don't see any currently, Misha, but if any come up, I'll let you know for sure.
That usually means that I've answered all the questions as I was talking.
It was very informative. So everyone keep an eye out in your email for a treat coming from us for attending. I guess if there aren't any further questions, make sure you join us August 25th, where we will continue to talk about prototyping in North America. Let's give you another chance. Anyone have any questions at all? Please put them in the question. I see a hand raised. Well, let's see. No, it doesn't look like we have any questions. So I think maybe that's it for the day. Again, everyone, thanks for attending, and we'll see you on the 25th of August. Thank you.
Thanks, everybody. Bye. Feel free to email me if you have any questions.
Bye.